So before to start the word problem, we consider one of not easy topic. You're going in United States classification, many books published in this issue, because in word problem you have to convert first of all text, formalize it, create equation, and solve equation. But if you formalize not good and created wrong equation, everything would be wrong. And some question, for instance, when I prepare for tests like GRE, it's when you have master go to PhDs, etc. Some questions, some text pretty tricky. They long, up to 1 page, and a lot of words, wordy very, and they have limited time. So my point, all these word problems not complicated at all. Plus, if you have equation, you can easily recognize these equations, quadratic or linear equation or irrational equation. For word problem, sometimes you don't know what tools to use, but there could be different equation in this case, right? Plus, when you have word problem, every time it's easy to change the text, the situation, and you have to recognize the test, this text similar to this text, and what method you're supposed to use. And sometimes you are tricked by this because you're not sure from which side to start, and you have these difficulties later when you have SAT classes or test or AP classes, different, etc., etc. My point is, I have a question soon. Who is interested in programming, for instance? In programming, you're doing some programming, right? Good, good, good. And what languages do you study in programming? Can you tell or type it? What languages do you study in programming? Yes, I need feedback to understand what you're doing. Okay, I see. Anybody else? Good. Anybody else? Okay, good. Very nice that you studied this. Actually, HTML, we don't consider language. It's kind of, but this is good that you study. I'm not criticizing this. If I look at the C++, Python, Java, C#, languages from Visual Studio, .NET, many languages you have, right? VB.NET, for instance. We started from C, which is function-oriented, to object-oriented. And object-oriented language is very efficient. I'm not going to go in depth of this one, but you know, when you go to abstract level, it's easy to solve problems because we have limited time. Impossible to teach every topic from scratch. We have to get general vision, and based on this, solve any problem in any test. Make sense? So definitely we don't have time for studying language, but you know, in object-oriented languages, let's say C is function-oriented and C++ is object-oriented, as well as some languages I know. And we have concept of classes and objects. So class, any class, if let's say from point of view Java, it has attributes and methods, right? Let me give some introduction and see how helpful it's for solving any problems from this test. So I use at the beginning here. After that, I put some information here. Let's say we have a class. A class. Let me create a class. Who knows what the UML stands for? UML. Anybody use ML? Raise hand. What does UML stands for? UML is a unified modeling language, right? And generally speaking, I have created a class. Let's say I create this class word problem. Somebody raising hand. Okay. So let me create a class word problems. Usually for class we use capital and we don't use spaces here. And we use Hungarian notation. We call Hungarian notation to make it readable, since this is one word, right? We use capital for readability. And this class, let's say I put a little bit bigger here. I represent this class. It has attributes. What attributes we have? Who knows what is attributes for Java we have? Any questions? Attributes, for instance, we can have, for this particular, I'm making some let's say attribute 1. If you make any analogy with your, I take handouts for any of these attributes. For instance, we have solution 1 when you study mixture. Solution 1. Solution 2. I need room for this. Solution 2. Solution 3 or mixture. And attributes are noun. Noun. Whatever you have. And this is one attribute 2. Attribute n. I don't know how many of these in our case, for instance, some problem 2, attributes 3. Okay. In addition, they have, if I put here some values, for instance, we have quartz. It's also value 1. And I'm not typing here data type, because any attribute has a data type. Either there's a string if you're talking about Java or text, or for instance, if you have 5 words as integer, we have different data type in any languages, right? I am not going to specify because our goal not to create a problem. Value 2. So this is string, for instance. This is integers, etc. Value 3. And you can write, for instance, this is 5 words, whatever, 3 words, and this is 8 words, whatever, somewhere. Or you can have percent of this acid. And let's say this is 30%, which is 0.3. And this is 60, which is 0.6, and this I don't know, right? And you can store here some attributes. In addition, we have some methods for this part. This first part, this is class name. This is class name. Again, I'm not going to use constructor everything because this is not our goal for this particular lecture, right? I just give you basic what we need for understanding how to solve any problems in your test. Now we have methods. Methods in Java or functions are the same. Okay, and usually we use one word starting from small letter. And let's say we have this 5 words and 30%. I apply method total value each. Value each. How you do this? I multiply this by this. And we name it, we invoke a method total value, one word, capital Hungarian notation, value each. And this method, I will not put here some, I will leave it parenthesis blank. And total value each one. And this for this one. Or I can use constructor, use this method passing different parameters of this. I can put total value for 2. Depends on our architecture. Another one. So, and I can easily count this is 0.3 times 5, 0.6 times 3, and x over 100 times 8. Okay. After that, just visually, I can create a method, create an equation. Create an equation or create equation. Based on information, so this works. For instance, you can add this plus this, and method no inside of we specify e equals to this. Okay, this is basic idea, and this is a class. This we name a class. Class for problem. What does it mean? Class for problems 1. So we can solve like a cluster many different problems using the same approach. And in object-oriented programming, when you have a class, we can make instance of this class with the object. Usually for computer programmers, they use idea of cookie and cookie cutter. This is cookie cutter form. If you use instance of this, for instance, class new and give name this, you created object, which has this property is just cookie. Cookie cutter when you make a physical object. And what is beauty of this approach? So 85% of this question for this word problem use the same idea. And the object, everything is object built on class. For instance, even student is object. Why? Because student has what? What kind of property we have? First name, last name, social security, address, height, weight, etc., right? Or sometimes when we had classes for small kids for object-oriented game programming, object-oriented languages many years ago. And we wrote a book about this even. And we sold it for India. So kids name this object thingy. You know, small kids, they use word thingy. Everything is thingy. And this is good because whatever they give you, if you think from abstract way, from this point of view of objects, is a thingy. People who created tests, they changed thingy. In our case, for instance, we study with you mixtures. It could be mixture of acid, mixture of alcohol, mixture of money, mixture of everything, of cookies and nuts, all of the mixture. Because we study what? Thingy. If you study, based on this, we develop this approach, generally speaking, right? We can solve any, practically, up to 90% of problems based on this approach, whatever they give you. It's not only about mixture. It's coin problems. It's that you will see, even today we practice with this. Any question about this part of lecture, students? Who understand so far, general idea? I give you abstract thinking because we don't have opportunity to study every time small thing. If you know class, for instance, we study class of mammals, right? And we have, if biology, and we have hierarchy of these classes. If this is mammals, class mammals, with all attributes, right? With attributes and methods, right? We have this and this. And let's say I have a class cat, which inherited property of mammals. I define everything here in class mammals. Automatically, cat inherited all these features because cat is a mammal. We name it is a relation for inheritance. If I specify somewhere in a class detailed information about mammals, so easy for me to define this class of cat. Instead of writing a few pages features of mammals, I just say cat is a mammal which has whiskers, wherever some stuff, paws, etc. Right? Easy. If I have another class, let's say tiger, which inherited from cat, I can say tiger is a cat, and this is subclass, this subclass, superclass, etc. You know, parent-child relation. Why is it good? Because nothing you can create except a thingy. People who created tests. Whatever they create, some unusual object about aliens, you don't care. Because for you, everything is thingy. And you always win. Because it's an abstract way. You can say, well, I study acid. I don't know how to solve problem with sugar in nuts, for instance. It's the same method for all of them. If you look at this from this generalization, it's much easier to solve any problems. So if you don't have any question for this one, if you have classes for programming, a special lecture for this, you don't need this. It's just good idea for generalization, and you understand how to solve any problem, use the same approach. Always keep in mind that we have here attributes and methods or functions. So far, so good. This one part of this lecture, what I want to tell you, which is very important for understanding. And the second part, let me raise, I need more room. Any questions so far about this? If you don't have questions, I will erase this part. And few more words. I just erase this, I need just more room. I told you a few words about great scientist genius. I just not sure about his spelling, but his name is Fritz. Probably like this, Fritz Wiki. He is engineer and astronomer. I believe he was born in Bulgaria. After that, they immigrated to Swiss. And after that, he immigrated to and worked in Caltech, United States. And he used morphological matrices. Extremely great idea. And he developed morphological analysis. What is matrices in this case? We have different kinds of matrices. When you go to university, you study linear algebra matrices, all this stuff. But this is not like this. When you want to get variety of different combination, etc., we use special method of morphological matrices. And what he did, based on this approach, when he put in one coordinate, he put different property of stars, in another different property of matter, and he predicted before discovering neutron stars. And he predicted this word supernova. This is him. Extremely smart. And when he created this idea, you can Google him, I believe, right? When he worked in Caltech, he got 50 patents in different fields. And this method helped him to predict a lot. And during World War II, when Nazis created V2, super secret missile, and nobody knew this, but scientists knew about his discovery, they asked, is it possible to use morphological matrices to predict property of V2? And they created institute for him, and it was like previous century, not too many computers, especially this quality, you know, this stuff, right? Which computer use Alan Turing, it's just mechanical stuff, rotating. And they combined different variety of cases, and they predicted parameters of V2 without working. It's super secret missile. Why I mention this? We use different kind of matrices or charts, which helps to solve, because this classification, classes and object, very productive in computer science, but we have to solve this problem, every problem. And majority of questions we use as tools which develop in morphological analysis this nice scientist, Zwicky. And actually, we found that before him, in 13th century, it was a monk, which name is Lully, who also used method of morphological analysis to prove of existence of God in different variety of situations, right? But he did not know about this method, and he did it from scratch. So good idea if you I believe I spell it correctly, and you can Google this. What we did, let me solve now. I answer your question using these two parts. One part is classes and object formally object-oriented, and second, these matrices. If you follow this approach, any problem from this, like 90%, you can solve this way. This would be our tool. Okay. Now let me see what question did you ask. He is the first in the world predicted and used word dark matter for astronomy. This is him. Now exercise 6, and you ask me questions about exercise 6. Number 1. So we applied this method, combination of these two parts, and create these matrices. Number 1. Express in terms of x the value and sense of x pounds. Okay, we have two kind of different cookies. Let's say I use cookies 1 and what they said, and we have 2. Just read what they have. Cookies 2. We will create a matrix. And look at this, what is given. This is 40 cents cookie. Cents. This is 40 cents. And they said we have pounds. And I just incorporate what they give you. X pound 40 cents cookies. And 30 minus X pound. And 30 minus X pounds. Or 50 cents cookie per pound. 50 cents. Okay. It's not visible copy. Let me take another copy of this one. Not copy. Probably this is better to see what is here given. Yes, this is better. And now I use a method, I invoke a method, total value each. Total value each in cents. Product of these two. 40x and 50 times 30 minus x. Based on previous explanation, they ask you to what to do? Express on term total. So total of total. You add them up. It's not even equation, expression. And you have 40x plus 50 times 30 minus x. It's it, just look on which format they are presented. They are represented in open parentheses. Okay, this would be 40x plus 1520 and minus 50x. Or combine like terms, and we have 1500 minus 10x. If you look at multiple choice, this is C. Okay, we do it semi-automatically. Use attributes. Any questions? Who understand up to this point? 100%, 100. Okay, Isabel. So soon again, this key thing. If you understand this concept, after that, one by one, we do it without any difficulties. Number 2, few students. Number 2. How many pounds of nuts? Number 2. We have different kind of nuts. one 70 cents, the second is nuts 2. And you get mixture. If you remember previous pictures, we had attributes. Now, let's see what we have. They provide you price. Price in what? Let's use cents per pound. What else if you read this? They have pounds. And total value each. Okay. Now, incorporate data. They said this for 70 cents. This is 90 cents, just incorporate. And this is, they said, 85 cents a pound. Good. What about the amount of this? They said this, they ask you how many pounds and put in oval. Oval means what question you're supposed to answer. And how many of this one? They said 30 pounds. If you put in the box this and this, you get X plus 30. Just simple. You have boxes and you put in this matrix everything. Now we invoked or call method total value each. Find these parameters on computer science, and system will give you 70x, and this is 30 times 90, doesn't matter which order we have, and 85 times x plus 30. And you combine these ingredients, you get this total. So far, so good. Now create, invoke method, create an equation we have, right? 70x plus, since it's whole number, we don't need to change anything. It would be 27 into zeros equals to use distributive 85x to 40 and 15, what we have to 550. After that, isolate variables. Minus 70x and minus 70x. Minus 2550 and minus 2550. Cancel. Cancel. This 15x. And this is 150. Right? And they ask you to find x. Divide by 15. And this would be 10. 10 what? Pounds. Who understand up to this point everything? Good, Karen? Yes. Number 3 questions. Again, if you have any question, without hesitation, ask me. Number 3, container, hold 10 pins of solution. You have a solution, number 3. I will name it solution 1. And we added pure acid. And we have mixture. If you read this, what they give you. We have three attributes. I don't care. For me, it's just kind of thingy. You can think here thingy also, not all attributes. And read what they have. 3/4. What percent result mixture is acid? Okay. So you can put in different order. Let's say percent of acid. And this is pence. And this is pence of acid. Okay. Now, incorporate this data. This said, this is 20%. 20%. This is given, which is 0.2. If you have pure acid, pure, it means nothing else. It's 100%. If you divide by 100, it's 1 at this point. And they ask you, what percent is this mixture? Is acid? I don't know. I can put here X. Now pence. How many? They said this is 10 pence. And this column is pence. 3/4. 3/4. I can put here 3/4. I have to put 3 times 2, 6 pence. Convert the 3/4 to pence. Everyone know how to convert, right? Must be the same unit like it's denoted here. If you combine this and this, you're supposed to get 16. And this column invoke method for total value each. Total value of pence of acid in solution number 1 is 0.2 times 10. And this is 1 times 6. And this X times 16. If you combine this and this, you get this. And York method create an equation. And you can write, for convenience, I can start from this part. X times 16, right? Which we have. X times 16 equals 0.2 times 10 is 2. And this is 6. And 2 plus 6 is 8. Right? 2 plus 6. Divide by 16. Cancel out. And this is 1/2. And I use X over there because I multiply without dividing by 100. And they ask you what percent. How to convert number to percent? If here divide by 100, they have to multiply by 100. 1/2 times 100, which is 50%. Okay. Who understand up to this point? 100%. 100% of this. Matvey? So if you have question without hesitation, ask me. Practically every year they give this kind of questions. And you like it because whatever they give you, you know that it's thingy. Impossible to create something new except for thingy. Number 4. Number 4. The solution 60 quarts of sugar. We have again solution 1. We connect it with water, combined with water. And you're supposed to get another solution with different concentration. Solution 2. This approach helps you to do anything because we don't care. This is sugar, acid, alcohol. Nobody cares. All of them thingy. Now, value what they have, they said they have number of quarts or percent of sugar, any order. And this quarts and quarts of sugar. Incorporated with data. What they said. This is 20%. 20%, which is 0.2. What are you supposed to write in this cell? Type me. What are you supposed to write in this cell? Just type. Over there. Okay, for feedback, type me what I'm supposed to write. In control panel. Okay, good. Yeah, but type preliminary. After that, go to bathroom. Type just what I'm supposed to write here. I want to see how you understand. Just type number and go to bathroom. Some of you who ask me. Everybody, try. I'm not criticizing you, right? I want to see feedback. Anybody else? Come on. Mia, why you use browser here in my room? You can't use browser, any browser. Mia? Except of this, you can't use anything. Mia, you can hear me? Okay, some of you wrote 80%, 5%, 7%, 0.8. Okay, I give example. This everything very logical. Everybody taking shower, right? Imagine they have in water 80% of sugar. Will be happy. You go outside, all bees around of you because in your water you have 80% of sugar. There is no sugar in the water, right? Do you agree with this? Yes or no? Common sense. This is 0. Many of these answer question, many not. But this is 0. For sure, because water is not sweet. Okay, and finally, solution 2, Daryl, you can go, you ask me. And they said to get 5%. 5%. To convert this to decimal divided by 100, it would be 0.05. And this 0.2. What about quarts? They said 20% of sugar. No, 20. They said number of quarts, 60 quarts. How much water? I don't know. But this combined solution would be 60 plus x. After that, I invoke a method, or we name it computer science programming method, value of each, and would be 0.20 times 60. And this is 0, because 0 times x is 0. You can write E0 times x. And this is 0.05 times 60 plus x. And formal way, if you combine this and this, you get this. So you can write 0.05 times 60 plus x equals 0.20 times 60. And after that, I multiply both part by 100, get rid of decimals. I have 5 times 60 plus x equals 20 times 60. Open parentheses, you have 300 plus 5x equals 12 and 2 zeros. And minus 300 and minus 300. Cancel out, you have 5x's equals to 900. Divide by 5. And next would be what? 180. And look at this, what they ask you about. They ask you x, put this in oval. This is the answer, 180 quarts. Who understand up to this point? 100%. Okay, no problem. No problem here, understandable. Who has questions, students? No question. Who understand this up to this point? 100%. Okay, good, good, good. Excellent. And the last one from this one, how many students ask? 5 students. And finally, number 5. Number 5. Again, we use matrices again. How much water must be evaporated from, so we have, so again, attributes. Solution 1, water, and solution 2. Now, provide values we have here. What it said? Okay, pounds. Let's say pounds. Initially, we have 240 pounds. How much water? They don't know, we don't know either. X. But this would be 240 minus x. Why? Because water evaporating. It's like you put your kettle on the stove, you come here, it's empty because water evaporating, right? And next, what we have? Alcohol. How much is percent of alcohol? And we have 3%, which is 0.03. And we don't have alcohol in water, right? You agree with this? 0. And what else we have here? Final supposed to be 5%, strengthens, most stronger, which is 0.05. And total value each in pounds. And this 0.03 invoke this method times 240. And this is 0, 0 times x. And this 0.05 times 240 minus x. And before and after, it's supposed to be the same amount of alcohol according to this problem. Water evaporated, number of alcohol are left the same. And I have 0.05 times 240 minus x equals 0.03 times 240. After that, I want to get rid of these decimals. How? I multiply both part by 100 as usual. And I have 5 times 240 minus x equals to 3 times 240. And if you multiply, you will get what? 1,200 minus 5x equals to 720 minus 1,200 minus 1,200. Okay, for 80, I believe, right? What we have here. Okay. Negative 5x equals to negative 480. You divide by negative 5 both parts. Negative, negative cancel out. I got 96 pounds. Who understands this problem? 100%. Matvey? Who has question about this? Who like this question? Who like this problem? I don't like this problem. I will tell you why. Even though I show you a general approach to practically to any problem, right, for work problem for your test, every time you have to be not robot, not just put all this stuff. You have to think. I have a lot of reference book here, even these thousands of books. If I take any my reference, some of reference book related to chemical properties, and find property of water and alcohol, people who created this test, they don't think correctly. They do like you work like robot. Why? Ask yourself, what evaporated first? Alcohol or water? What do you think? Any ideas? We did it in assumption that alcohol evaporate not the first, the water the first. But if you look on chemicals, on chemical property, alcohol would be the first. So from point of view people who created this great problems, for exercise this is fine, but you have to ask yourself, is it possible or not possible? It's very important. Let's say some grown-up knows if you take bottle of alcohol, open this, forget to close, it becomes diluted, right? Not the same strong. You understand my point? Because according property of alcohol, it evaporates faster than water. But if you have this test, don't write, I disagree with this. No, don't do this. Solve it and be happy. Okay, so far so good. So if you noticed, I use the same approach using previous explanation about classes and objects and morphological matrices we apply for all these problems. Okay, so few questions from some students ask about bathroom. Yes, sure. This is, I agree with you, Mia, about tea kettle. This actually tea kettle in different connotations, just evaporation of tea. But definitely, idea of tea kettle in this particular case, I will tell you after the small break with somebody insisting to go. Yes, manager, I promise after this exercise you can go. So come here fresh and we continue with you. Put your hands down, students, hands down. Everybody, come back and raise your hand. Good. Waiting for you. Well, soon waiting for you. Real, better not to use browser because you're losing focus. Turn off your browser not related to this class. Even during break, it's not a good idea. Okay, waiting for you soon. Can you come here and raise hand? And I will know who is who. Okay, Ariel, Gabriel. Let's continue to second package. Let's go to the second package. For the second package, let me see. Practically, all of them very similar. Okay. Many students ask question number 4. Number 4. So this is mixture package, mixture. Number 4. We have solution 1. Read what is given. How many pounds of pins? And we have pure acid. We did similar today. We did. It's the same problem like we did today. Number 4. Practical, look at the students. Look again. Problem we move forward because all of this question I explained, they just have different number. But you have still struggled with any of this. Tell me which number you still look at this question. Very similar with some of them identical. Which question you would like? I will gonna go through this. So practically all of them what we have here. So far so good. Okay, if you have this everything, let me go through different objects. So mixture, we're gonna go, you'll be expert at this because every year they ask you this question, and this is zero creativity if you understand this algorithm, right? For instance, let me solve with you a different problem. I solve for myself because we don't have too much time. Write down the problem. Alex, problem number 1, or this one. Has blank consisting of blank and blank. It could be different coins. If he has blank more Let me put here nickels. And you can have in your homework different nickels. And then dimes. How many nickels does he have? I put some numbers here. 135. This is that. And let's say you this one also, nickels and dimes. If he has 9 more nickels. Remember, at the beginning of lecture, we use object-oriented approach. We have classes. We have attributes and methods. Let's apply. It's not mixture at all, like solution or sugar, wherever you have acids. But we have, again, attributes. And what attributes they said? They have nickels and we have dimes, right? Nickels. How many nickels does he have? Okay. Let's do this. What we have, I'll look at this number. We have nickels and dimes. Two attributes. And value of one coin cents. This is 5 and this is 10. Number of coins. Nine more nickel than dimes. If this is x, it's x plus 9. Total value each. In cents, for instance. It would be 5 times x plus 9. And this 10x. I had one more line here total. And this door 135, I put here 135 because everything is cents. Now, if I add this plus this, I'll get this. Because for me, coins, acid, sugar, alcohol, all of them what? Thingy. And now read the question, how many nickels? Put an oval, always put an oval over there, because you got x, who happy, but question about this one. Now, write equation. 10x plus 5 times x plus 9 equals to 135. Distributive 10x plus 5x plus 45 equals to 135. Minus 45 minus 45. And combine like terms. You have 15x cancel out equals to 90. Right? 90. And if you divide by 15 both parts, you have 6. But 6 not the answer. You have to grab and plug in over there. 6 plus 9 is 15. So for us, everything is thingy. So whatever they give you, use the same what object-oriented approach and use the same kind of equations and the same actual methods. Who understand this 100%? 100. Okay. So actually, what you go through when you go home at home when you do this, right? My request: you're supposed to do the same steps. Our goal not to get correct answer. Nobody cares. Our goal to have perfect tool where you solve any problems in your test wherever they give you, right? On this test or different test. So in this exercise, they have dimes, quarters, nickels, dimes, nickel quarters, all of them, but practically they use the same matrices. Or for instance, if they give you, let me read one problem. If they ask you, they have problems, look at this. A postal clerk sold certain amount of stamps, post stamps, for 5.40. Somewhere 10 cents, 10 cent stamps, some 15 cents stamps. How many 10 stamps were here? Can you see? Nobody cares. This is thingy. The same approach. Cents, diamond, dimes, nickels. The same idea. They cannot trick you at all. Okay. I have a question. Who need explanation for this coin problem more? Or I can go to another topic with also object-oriented. How you feel about this stems? About this coin problem. Who need help with coin problem more? No, put your hands down, everybody. Down. Down. Read. Raise your hand. Who need help with coin more problems? Coin. Let me solve one problem for this coin. One problem. I have special handouts for coins. Let me see this. A lot of handouts. I don't give you this from your homework. All of them not difficult at all. Okay, which one? Let me give you a problem. To find of nickel and dimes, we have. I make corrections all by itself, and after that I explain. We'll make some corrections, okay? So let me raise this one. Again, use the same approach, okay? A sum of blank doors is made Only steps, students. Again, I don't need your answer without the steps. Coins, I give you numbers. Consisting of dimes and quarters. How many are there each kind of coin? Okay, I will give these numbers, but my request, as you can understand, only use matrices, this approach. Why? Because our key to success, whatever they give you, I want to do it semi-automatic, like in wrestling, right? Understand this? Only this method. Thank you. Okay, 14. 92. Okay, good luck. The same steps and the same method. Good luck, students. Okay, one student solved correctly. Matvey, I will explain you in a few minutes. This second student also solved correctly. We need help for this for this problem. Let's do it together. What is supposed to do? Our attributes. We have dimes. And quarters. Value of one coin. In cents. Number of coins. The same structure like we did for a mixture. Imagine this mixture of these different coins. Total value each. In cents. For us, everything is thinking like we did before. We understand up to this point 100% everybody. Gabriel, Isabel, good. Matvey. This is 10, this is 25. Now, total, one more line, one more row. Like in database, we have rows and fields. We have number of coins, 92. And this x. And 92 minus x. And sum is 14, but this is cents, is 1400 cents. And this invoke method total value each like we did in object oriented 10 times 92 minus x. And this 25x. The same combination of this give you this. After that, you invoke method, create an equation. How to do this? Easy. 25x plus 10 times 92 minus x equals to 1400. Or 25x plus 920 minus 10x equals to 1400. Now 15x and minus 920 and minus 920. When you subtract, you will get 15x cancel out equals 480, I believe, right? Is it correctly? That's correct. Divide by 15. If you divide both parts by 15, and x is our number of waters, I believe you get 32. And you have to find each. How to find number of dimes? This is quarters. And dimes to get, you have to do what? 92 minus 32, which is 60. Okay. You can think about mere, this is actually you invoke also T-kettle method, because we studied this, how it's solved for different solutions, different mixture. And we have another mixture, imagine, right? And in this particular case, we apply the same method. Nothing special here. Nothing new. Who understand this 100% up to this point? If somebody got 52 and 50, this is not good expert. Nice try, but students, if you got 52 and 50, add them up. You're supposed to have 92, right? So something wrong. Okay. Probably, and one more thing. If you noticed, I always use behind the scene this my old-fashioned stopwatch. Because on real test, you have 90 questions. And we subdivide this question by two categories. Open-ended questions and multiple choice. And you have 57 questions. If you spend such amount of time for this problem, it's unreal to finish test on time. For previous years, students solved this test for 37 minutes with deep understanding what you're doing here. In 37 minutes, they triple check. That's why even though my plan was to go through many different topics, maybe it's not a good idea. Let's go in depth, two of them. First of all, make sure you go in depth. And second, coin problem. You get handouts for coin, but again, try to develop this skill. Most important, not the answer. Most important, this approach. So far, so good. So we have to develop two parameters so far. Conceptual thinking, you understand concept. And actually, don't forget about your time, limited time. You can also use stopwatch to see how fast you are. If you slowly, you will not finish test. If you don't finish test, you will not get enough score. Okay, it's supposed to be professional done, and this approach always helps you. Okay, who understands this question 100%? Why 100%? Okay, good.
Mr. Farber, can I ask a question?
Sure.
When you did the number of coins with dimes and you did 92 minus X for dimes, why didn't you do, say, 92 minus X for quarters versus dimes, if that makes sense?
If you go question, look at this. This is like you go to Broadway show and you get a paper, who is who, right? In Broadway show.
Right.
And we name it Math Legend. And this not only helpful morphological methods, it's also a legend. You know, quarters is X for sure, 100%. This X for quarters, you can't switch anything here. You can build different place, different table. You can denote this X, but this 92, and equation would be different. Want to see this?
Right. No, yeah, I do know it'll be different, I guess.
So if you found X, now, how to use X, where to place X, and where to put what is left. If you switch it, the result will be exactly the same.
Oh, okay.
Exactly the same. Only X, keep in mind this one, and this 92 minus X. Result is the same. Only keep in mind that in this case, X is related to these dimes, and this related to quarters. What do you think? What is better, this one or this red one? What do you think, Karen?
Well, the dimes is better. The dimes is better.
So actual result is the same, but my suggestion, since sometimes kids under pressure make a mistake, better choose X for bigger number.
Okay.
Why? I will look at this, what happens. if I use this one instead of this column, I use another one. This column would be 10x, right? And this would be 25 times 92 minus x. And this, if you add them up, I'll get this one, right? This one. And let me write this space.
But it's a lot more difficult.
It's not more difficult. It's not more difficult. I'll show why. Result absolutely the same. Equals to 1400. But look at this, 10x plus, when you multiply these two numbers, what you're supposed to get? Just tell me what you will get. Okay, probably you will get what we have here. We have 92 minus x, right? It would be 2300 minus 25x equals to 1400. Very nice question. Now combine like terms, and now we operate with negative numbers. You see the difference? The result would be exactly the same. So it would be negative 15x, cancel out, and this would be negative, I believe, 900. If you divide by negative 15 both parts and cancel out, you'll get 60. But what is like 60? Is dimes. Dimes. And compare what we have here, the same result. And how many quarters you have? 92 minus 60, which is 32. And these quarters. Only in this case, we don't have negative numbers. In this case, we have negative numbers. For kids, it's slightly better to operate with, is more natural. But result exactly the same. Only keep in mind who is who. Did I answer question?
Thank you. Yes, it did. Thank you so much.
No problem. More questions, students? So again, always choose, if you have, it doesn't matter, but better to choose for bigger numbers, x. In this case, it would be, sometimes when you operate with negative, you're losing sign and everything is wrong, even though you know everything. The easier, the better. Okay. Ready for another question? Well, let me give another question. Which one? For instance, this one. It's very natural questions, right? Tom and Jerry, not this from your cartoon, different Tom and Jerry, bought a used car together for blank doors. If Tom paid let's say 110 more than Jerry, right? How much did each pay? I put numbers here. It's very used car for $450. Good quality, right? It's 110. Not 100, 110. Good luck. Again, the same way, students. Use your opportunity. Yes, Andrew. So I deliberately give the easiest way because here we don't have too much time. I want to see how fast you solve. This is easy, definitely even easier than previous one. But very good. Yes, Andrew. Yes, Ariel. I know who likes Tom and Jerry. If you did correctly, I say yes. If you don't do correctly, I will not name you. If I do not name, it means be wrong. Okay, good, 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 good. Good, Maxim. Good, Emma. After that, I'll give you one more question. One more. We do not finish. So, Emma, yes, pass. Maxim, pass. Mia, yes. Ariel, yes. Joshua, yes. Okay, I know this for warming up. Let me do this very fast with you. Be ready for another one. I just want to see if I simplify, how fast does it take. I measure time. What do you have? This is faster, Tom and Jerry. Okay. Door spade. This x plus 110 total. Add them up. You have 2x plus 110 equals to 450 minus 110 minus 110. 2 x's cancel out equals 340. Divide by 2 both parts. You'll get what? 170. Who is 170? Jerry. And this guy is 170 plus 110, 280. Understand 100%. This is easy, right? Since we just warming up, let's do this. Matvey, question? No question? Okay, good, good, good. Let's do this one. Now, this one. Alex had consisting of, let me put this, nickels, dimes, and quarters. This is faster. You understand this? And NDQ, nickels, dimes, and quarters. For simplicity, if number of dimes exceeded the number of nickels, by 1, and the number of quarters was equal to the number of nickels decreased by 1. What was the number of each kind of coin? Let me use, let's check. Consider nickel, dime, and quarter. If the number of dimes exceeds the number of nickels by 1, this is 1, and the number of quarters was equal to the number of nickels decreased by 1, was the number of each, and now $2.65. $2.65. Good luck. Yes, 2 students pass so far. Emma, Andrew. When you have with these problems, put your hands down, everybody. Put hands down. And tell me, hands down, everybody. Down, down, down. David, Emma. When you have for this problem, put your hands down. Who need 1 more minute? Okay, give you 1 more minute after the table have. Yes, Joshua. Anybody else? Okay, let me explain this. So again, use the same idea of object-oriented approach and the same way of this for matrices. So what we have? We have nickels, dimes, quarters, right? They said nickels, dimes, and quarters. Create this matrix: nickels, dimes, and quarters attributes. Incorporate values. So value of 1 coin in cents, 5, 10, 25. Number of coins, and total value each. Exactly like we did for all our problems. Now they compare everything to nickels. They said exceed by 1 is greater than 1, and this is less than 1. This is product of these two. 5x 10 times x plus 1 and 25 times x minus 1. And total is 265. If you add them up, you have 5x plus 10, x plus 1 plus 25, x minus 1 equals to 265. Distributive. 5x plus 10x plus 10 plus 25x minus 25 equals 265. Combine like terms. I continue with that. Don't have 5x, 10x, 25x is 40x. Combine these numbers. Minus 15 equals 265. Plus 15 and plus 15. 40x equals to 80. If you divide by 40, those parts, x equals to 7. So this is 7, this is 8, and this is 6. That's it. So, students, again, keep in mind what we did today. Today we cover a great idea, object-oriented, to think conceptually for any thingy, either this mixture of different solutions with acid, alcohol, sugars, whatever you have, stamps, coins. We use the same approach everywhere. You see this? Good idea. At home, do the same steps. So far, so good. So I'll show how we apply this approach for many of these questions, and this great idea to structurize your knowledge on this case. It's number one. Second of all, I made a presentation, I don't know, told you or not, in World Congress in Cambridge in England, and based on this, and another Congress in Trees, and based on this, I made a presentation just a couple of weeks ago in China, in Beijing, about education. It's a good idea to know where we go. And you understand deeper what you're doing here, because what we see, you see only tip of the iceberg. You see a little bit behind in the depths what you're doing. If you'd like this, manager will send you this this presentation. Who would like to get this? Then she send it to your email for everybody. Okay, who raising hand? Okay, look at this, because education is key thing. You study many years and nobody teach how to study. They give this assignment. Now, what is your hope? Do you have any questions for today's lecture? No questions. Did you have fun today? Question mark. Tired? Now,